What happens when a material exceeds its elastic limit? Imagine bending a paperclip back and forth. At first, it springs back into shape, but push it too far and suddenly it stays bent. That's what happens when a material exceeds its elastic limit. When you apply stress to a material, it stretches or compresses. Up to a certain point, called the elastic limit, the material behaves like a spring. It will return to its original shape once you remove the force. This is because the atomic bonds inside the material stretch but don't break. Think of it like stretching a rubber band. It snaps back after you let go. But if you keep increasing the stress beyond this point, the atomic bonds start to change. They break or shift, creating permanent damage inside the material. This is called plastic deformation. Once the elastic limit is crossed, the material no longer fully recovers its original shape. Instead, it stays deformed even after the load is gone. This change happens because of dislocations, which are tiny defects in the crystal structure of the material. When stress exceeds the elastic limit, these dislocations move or multiply. They allow atoms to slide past each other, creating a new shape. It's like pushing a pile of bricks so they settle into a new position. In practical terms, if a metal part is stressed beyond its elastic limit, it will have a permanent bend or stretch. The stress-strain curve shows a clear shift from a straight line to a curved, nonlinear path. The material might also become harder but less ductile. Ductility is the ability to stretch without breaking, and this usually decreases after the elastic limit is crossed. For brittle materials like glass or ceramics, exceeding the elastic limit often results in immediate cracking or shattering. They don't have the ability to deform plastically, so they break suddenly. Understanding what happens when a material surpasses its elastic limit is vital for designing safe products. Engineers want to keep stresses below this point to avoid permanent damage. If a component is overstressed, it can lead to cracks, failures, or complete breakdowns. That's why safety margins are built into most designs, ensuring the material stays within its elastic zone during normal use. So, in simple terms, crossing the elastic limit turns a material from a flexible, spring-like object into a permanently deformed one. It's the key to understanding many product failures and mechanical breakdowns we see around us every day.